We have an electron that is accelerated from rest to a potential difference of 1200 volts. It then enters a region where a magnetic field of 80 microteslas is oriented perpendicular to the electron's motion. What is the radius of the electron's motion in the magnetic field? So the potential difference accelerates the electron, gets it moving, it has a speed. Since the electron is now moving perpendicular to the magnetic field, it feels a force. And the magnetic force always makes the charges move in circles, so we want to know the radius of that circle. So as far as finding the speed, we know from conservation of energy that delta U is equal to negative delta K. And we know also that delta U is Q delta V. Well, might as well substitute in too. We know change in kinetic energy is final kinetic energy minus initial. But there was no initial kinetic energy because it was at rest. So solving for speed, let's get the 2 over here, negative sign, mass. Charge on an electron, negative 1.6 times 10 to the negative 19 coulombs. Delta V was 1200 volts. Mass of an electron, 9.11 times 10 to the negative 31 kilograms. So the speed of this electron ends up being 2.05 times 10 to the 7th meters per second. Now, as the charge enters the magnetic field, it's going to feel a magnetic force. We know the force, the magnetic force on a moving charge is QV cross B. We're told that it's moving perpendicular to the magnetic field, so we can simplify this. The magnitude of the force will simply be QVB. According to Newton's second law, that has to equal ma. But the acceleration is a centripetal acceleration. So v squared over r for a. So if we solve for r here, one of the v's cancels. That leaves us with mv in the numerator, and we bring the q and the v down. Now in this equation, we're talking magnitudes only, so you don't need to put negative signs on your charge. So the mass of our electron, we know. The speed of our electron, we've figured out. The charge of our electron. And our magnetic field. So plugging that all through, come up with 1.46 meters. It's a pretty big radius, but our charge is moving awfully fast, and the field it is in is not particularly strong. What direction it will circle depends upon the actual direction of the field and velocity. We would need to know what direction the field is in. So for example, if we knew the magnetic field, whatever was creating it, don't really care what it is. If we knew the magnetic field was coming out of the board, and we knew our our electron was headed to the left, what direction would the force be on it? Which way will it circle? Will it circle down this way or up that way? Let's do the right hand roll. Index finger in the direction of velocity, that way. Magnetic field is out of the board. My thumb is pointing up, but the electron is negative. So it will circle downwards. So V cross B is up, but for the fact that Q is negative, it will